Welcome to Saucy Math. This video is going to be about multiplying and dividing rational expressions. And rational expressions are expressions that are written as fractions. Alright, so basically we're just going to do one example here because it's a pretty big example. It's going to take a while. So we have what we call a compound fraction, 2x squared minus 3x minus 2 over x squared minus 1. Alright, that's in the numerator of our fraction. That whole thing is over another fraction, 2x squared plus 5x plus 2 over x squared plus x minus 2. All right, so I know a lot of people, your first reaction when you see something like this is just like a huge mess of crap, and how do I even begin dealing with something like this? All right, and you're right, this is a huge mess of crap, but just like most other math problems that look like huge messes of crap when you first see them, once you recognize what you have and then you understand the procedure of how to work with it, it's really not that bad to do. All right, and this one is the same, although this one looks more messier and crappier than most problems do. All right, so with a compound fraction like this, where we have a fraction in the numerator and then another fraction in the denominator, the way I like to start something like this is to rewrite this thing, instead of it being a compound fraction, rewrite it as a division problem. So I'm going to make this 2x squared minus 3x minus 2 over x squared minus 1, right? That's my smaller fraction within the numerator. But remember, a fraction means that you're dividing. So it's this fraction up top divided by the fraction in the bottom. All right, so it's 2x squared minus 3x minus 2 divided by the denominator fraction, 2x squared plus 5x plus 2 all over x squared plus x minus 2. Right, and with a lot of other problems in math, especially ones that are this detailed and have this much stuff going on in them, be real careful that you copy down all the stuff correctly, because if you miss a minus sign somewhere or write down the wrong number, it just completely screws up your entire problem. All right, so if we take that compound fraction and rewrite it as a division problem, it doesn't look quite so bad. I mean, it still looks pretty bad, but it's not so bad. All right, so we have this fraction divided by this fraction. If we remember way back when you learned the rules of how to do operations with fractions, the rule for dividing fractions is you keep that first fraction the same. So 2x squared minus 3x minus 2 all over x squared minus 1. You flip over or use the reciprocal of the second fraction. So I take this second fraction and I flip it over to x squared plus x minus 2 all over 2x squared plus 5x plus 2, and I change my division to multiplication. Right? Dividing by a fraction is the same as multiplying by the reciprocal of that fraction. Right? And if you approach it like that, it takes what we started with, this ridiculous looking compound fraction, all right, we change it to a division problem, and then we just use the rules of fraction to change that division problem into a multiplication problem, and now we have to multiply these two rational expressions to arrive at our solution. Right, so I know that when I said at the beginning that this video is about multiplying and dividing rational expressions, then the reason we're only doing one example of dividing, because every time you work with dividing rational expressions, it turns into a multiplication problem. Right, so if right now, the homework problem or whatever it is you're trying to do, if it's a multiplication problem, basically you're starting from this point and then you're just going to do whatever we do from here. Right, if you start with the division problem, you just flip over that second fraction and change it to multiplication, and it just kind of simplifies into a multiplication problem. Right? But now the problem is, how do I multiply all this stuff together? Right? Your first instinct might be, well, I can take all this stuff up here and multiply it by all this stuff up here, because when we multiply fractions, you multiply the numerators together, and then you can multiply the denominators, all this stuff, the x squared minus 1 times all this over here, and just kind of multiply all that out and see what it equals, and that's just going to leave you with a whole big mess of stuff, which then you would have to try to simplify, which is going to be pretty difficult to do if you multiply all this stuff together. Right? So a better way to do that, and you're going to be doing this anytime you try to multiply or divide these rational expressions, is to factor each part of your expression. All right, so I'm not going to spend a lot of time talking about how I factor these. If you're not sure how to factor, I've made quite a few videos about the different factoring methods, so you can check those out to kind of get some background on how the factoring works. But this first thing up here, this 2x squared minus 3x minus 2, that factors into 2x plus 1 times x minus 2. All right, so if I factor this, I end up with this, and just like with any other types of factoring thing, if you multiply all this together, you can double check that it adds up to what we have up here. All right, and I'm just doing that in my head real quick to make sure that I have this all written down correctly, and that looks good. All right. Then I factor my denominator of that first fraction, the x squared minus 1. All right, that's a difference of two squares, which factors into x plus 1 times x minus 1. All right, and then this is getting multiplied by my second fraction. And I'm going to do the same thing and factor the two parts of that second fraction. So up top I have the x squared plus x minus 2, which that's going to factor into, let's see, x plus 2, x minus 1. All right, so x squared plus 2x minus 1x minus 2. And I was just kind of going back through to make sure that when I multiply that out, it gives me what it's supposed to. And then I'm going to factor my last part, this 2x squared plus 5x plus 2, which factors into 2x plus 1 times x plus 2. All right, so anytime you're doing one of these problems that involves multiplying or dividing the rational expressions, usually there's going to be factoring involved. And also when we do adding and subtracting rational expressions, a lot of times we have to factor things as well. All right, so like I said a couple minutes ago, if you're not real good on the factoring, you can check out some of the other videos I've done that explain how to factor these things, because that's a key part of doing these types of problems. All right, and now that we've factored everything, basically what we look for, and the way we're going to simplify this, is we are going to look for any factors in our numerators and any factors in our denominators that match up that we can cancel. All right, so for example, the first factor I have up here, 2x plus 1, over in this fraction, I have another factor of 2x minus 1. If I have one on the top and one on the bottom, those are going to cancel out. Right? And remember, when it's multiplication, we can do this. Right? And when we're multiplying two fractions, any factor in the numerator of either one of the fractions could simplify with any factor in the denominators of any of our fractions. Right? What you can't do is you can't simplify something in this numerator with something in this numerator. Right? It has to be something at the top and something at the bottom. It could be within the same fraction or within the two different fractions. Right? So that's canceled out. We have an x minus 2. We don't have any other x minus 2, so that one's going to have to stay. See, we have an x plus 2 in this numerator. We have an x plus 2 in this denominator, so those two can cancel out. I have an x minus 1 over here and an x minus 1 down here, so those two are also going to cancel out. And as you can see, almost everything cancels out, and all we're left with is an x minus 2 up in our numerator and an x plus 1 down in our denominator. Every other factor that we had cancels, so that is going to be our final, simplified answer to this division problem that we were given. Right, and you're going to see that happens a lot when you do these problems. When you factor all the stuff in your numerators and denominators, a lot of those factors are going to cancel out, which makes it a lot easier to simplify what it is that you have. All right, so that is an example of dividing rational expressions, which, like I said a couple minutes ago, anytime you have a division problem, it's going to turn into a multiplication problem. So it's kind of like you're doing the same thing whether you're dividing or multiplying. Right, every division problem eventually turns into multiplication, and then you're just factoring and canceling out the factors and then just writing down whatever's left behind. All right, and I'm going to make another video about adding and subtracting rational expressions, so make sure you check that one out.